go. We got the new recorder going on. Okay. All right, so let's go to the concepts first. So instead of just staring at the homework assignment, what I'll do is I'll point out where you can find information that is related to passing by reference. So that way, if you need to look up the notes or whatever, you know where to look. Those are all in topic 7. So this is topic 7. Within topic 7, there are a lot of links. As I said, in the past, just read the last one, which is updated subroutine notes. This is the one that is updated. And in here, we have talked about invocation and returning already. We talked about local variables already. In this class, we also talked about passing by value. Okay, passing by value, as a quick recap, is kind of like local variables, except the initial value of a pass by value parameter is specified by the invoke statement that get you into the subroutine in the first place, whereas a local variable always starts with an unknown value. We'll get a chance to talk about those concepts as well, just in just a little bit. But what the focus of today's class is on pass by reference. So we want to understand how parameters can also be passed by reference as opposed to passed by value. And after today, possibly, at the end of today's class or on Tuesday, we'll start to talk about returning values, which can be confusing for some people, but the rule is pretty simple. The mechanism itself is simple, but to some people that can be kind of confusing, especially in a recursive setting. So we'll talk about those next Tuesday, most likely. But today we'll focus on by reference parameters or passed by reference parameters. All right. So getting to a spreadsheet to show you basically sample code, let's start with something that we already know. Okay? Let's start with a subroutine that is supposed to exchange the values of 2 parameters. Okay? So we'll give the subroutine swap 2 parameters, by val x, by val y, and we'll have a local variable t. So this is also a very good opportunity to kind of review the concept of passing by value in order to understand its limitations. Okay, what can't we do with passing by value? That is the focus of this for this particular sample program. We'll use t to remember the old value of x, and once we remember the old value of x, we can use x. We can store the value of y in x, and then we can update y with the old value of x, and that completes the exchange of the 2 values. So we'll define sub here. And then in the other subroutine, we'll define another subroutine, let's say sub 1 here. And in here, I can have local variable x, local variable y, and we'll just say that x starts with a particular value of, let's try 46, and y starts with a value of -7. And then we'll invoke the subroutine swap. We'll use my local variable x to specify parameter x. We'll use my local variable y to specify parameter y. And, and that's it. That's the only thing I have to do to invoke the subroutine swap. And outside of both subroutines, I just have to invoke sub 1. That's my entire program. So let's fix the indentation first. We can trace it. And by the way, is enrollment open to everyone already, or is it still?
I think it's
open.
First priority.
Tomorrow's first.
Yeah, mine is May.
No, it's not open to everyone yet.
The 28th of this last month was priority 1, and then it opens to everybody on the 19th of May.
Oh, there won't be much left.
I got
I'm May.
Monday, and they were already started.
Or no.
Oh, really?
My deadline is last Friday.
Oh, yeah.
I think just anybody trying to get in that did, have questions or something like that.
So it is still really hard to get into classes because I think the college is getting slightly more funding than last year. So the number of sections should improve a little bit. Yep.
I know your class 360 is already waitlisted.
Is it
Yeah.
waitlisted?
Yeah,
Okay.
it usually does, yeah.
Yeah, I think all 3 sections are like that. You know, if you check out the other 2 sections, I'll bet you they are on wait list already.
So if you're 8 or 9, you're gonna get in. If you're 8 or 9 on the wait list,
Just wait, it'll drop eventually during the summer.
The great
Or in
thing
2
is
weeks
with the
when
fall
people don't pay for it.
semester, you have the whole summer. So you have the whole summer and people don't
For
pay
people to
their
get out.
tuition and so they automatically get dropped
Oh,
and
yeah.
you get up that ladder faster. Your chances of getting in on a wait list is much more in the fall.
Interesting. I did not know that. I did not know it would have any impact,
You didn't?
whatsoever.
Yeah.
If I get into a class, I just pay right away. It's like,
Yeah.
okay,
People don't
let's
pay
not
in those
forget
2
it.
weeks, and then they might forget about it if they don't pay it up front, and so or they might need to drop out because something came up. Or,
Yep.
you know.
And no,
Okay.
the thing I don't like about the wait list is because you won't have 12 units on the wait list. I like that.
Okay, well that's
Because sometimes I usually want more costumes.
Yeah,
I'll wait
yeah.
list.
all right. So let's go back to this code here, and I'm just double checking to make sure that I am recording. Okay, it is good. Because sometimes I forget to specify the microphone channel. All right. So here's the sheet 2, which is okay. Let me make sure this is the right one. Nope, that's the wrong one. This is your actual homework assignment. Let's close that first.
Could have done that
That
one.
would've been nice.
No, but I'm just going to trace it in that spreadsheet, so it's not going to help. All right, so we'll still trace the swap subroutine here. Now this is interesting because up to now we always have global variables. This is the first program that has no global variables whatsoever. In other words, in the trace we just have line number, and that's the only column that we have to allocate initially. And as for the precondition, there's nothing to say. There's nothing to say because there are no global variables whatsoever at this point. So the precondition actually doesn't have to say a single thing. Now let's double check that we do not have any global variables. In subroutine swap, we refer to the names t, x, and y, but they are all accounted for by the local variable t, by val parameter x, and by val parameter y. In subroutine sub 1, we refer to x and y, but they're both accounted for by local variable x and local variable y. So there are no names, no identifiers whatsoever that we refer to that are not accounted for by val or local, and that's why this program has no global variables. Okay, well that makes things kind of not easier but interesting. So on line 16 we invoke sub 1, and sub 1 is going to allocate several columns. In fact, it will allocate exactly 3 columns. One for the return line number, one for local variable x, and one for local variable y. Local variable x and y as local variables always start with unknown values. The return line number is going to be post because line 16 is the last line of the entire program at this point. So now we get into the subroutine sub 1, and on line 12 we start the actual execution. X gets a value of 46, okay, and on the next line, line 13, y gets a value of -7. And then after that we get to line 14. Let me just kind of make these columns a little bit shorter or narrower so we have more space left. On line 14 we invoke subroutine swap. Subroutine swap has a return line number. It has by val x, by val y, and local variable t. Local variable t is the easy one. It always starts with an unknown value. So next we want to go back and look at the other 3 columns. The return line number, not too hard because the invocation is on line 14. So the next line is line 15. So the return line number is going to be line 15. All right. So now the question is, what do we specify in x and what do we specify in y? On line 14, it looks kind of confusing because it looks like it's circular reasoning. I'm using x to specify x. But the x on the left-hand side refers to the x that I should know already at this point. The x on the right-hand side refers to the x that I'm setting up. So that means the x on the left-hand side is referring to column C, whereas the x on the right-hand side is referring to column F. Is that okay so far? When you look at line 14, okay, let me just point to line 14 here. This x is referring to the x that is already known to this particular subroutine. That is column C. The other x, the x on the right hand side, is referring to the parameter of the subroutine that I'm invoking. Okay, I'm invoking subroutine swap, and parameter x of subroutine swap is column F, and that one is the one that I'm trying to determine. Now, since this is passed by value, that means I also have to specify the actual value here, which is 46. It is not okay, it is not correct to just write down x here. Okay?
It's a value.
Sorry?
No, I just said it's a value thing.
Yep,
not
it is. It
exact.
has to be a particular specific value. Cannot be a name of something else. Cannot be an expression. It has to be a specific value. So the same reasoning applies when we use y to specify y. The y on the left-hand side refers to the y of subroutine sub 1, which is column D. It has a value of -7. Since we are passing by value, we also want to specify -7 to the parameter y in swap. Oops. Okay, there we go. So are there any questions about how the columns are set up at this point? Okay, we use x to specify x, we use y to specify y, and since they're both passed by value, we just copy the value around.
Those are considered the by values?
Yeah, these are by value. And we'll see the limitation of passing by value in this particular program, and then we'll change it to something else that can fix the problem. So after line 14, we get into the subroutine that we're invoking. We're invoking swap. The first line of swap that actually does something useful is on line 5. So we continue on to line 5. These 3 lines are not very mysterious. We store the current value of x in t. The current value of x is 46, so t becomes 46 as well. The next line is going to copy the value of y to x because I just saved the old value of x. It is now okay to overwrite it. So y has a value of -7. I want to store it in x, so x now becomes -7. And on line 7, I use the old value of x, which was stored in t, to update y. So 46 is in t, so y now ends up with the same value of 46.
Nine.
Oh, round 9. Okay, right there. Today is kind of funny because my monitor is all dark. I cannot see anything here, and that's why I keep looking at the screen. Yep.
Say if x didn't update to t in the by values, then how would you update y?
You mean here on
Yes.
on this row?
Yes. If x had not updated to t.
Well, x is already updated to -7.
Well, so you have to update y with the t. What if t wasn't updated with x?
And we have a problem.
Yeah.
That's why the first thing I do is to save the value of x in t, so that on line 7 I can refer to t as the old value of x before I overwrite it, and so that's how y can end up with the value of 46.
Okay, you just said with the old value, so I wasn't sure.
Yeah, the value prior to the overwriting of that parameter.
Okay.
Okay, so if you just kind of focus on these 2 columns at in this time frame, the swap operation or the exchange was successful. Okay, I did exchange the values successfully, but then when we get to line 8, something bad is going to happen. Because on line 8, which is the end of a subroutine, we got 2 things to do. The first thing is not destructive. The first thing is really just to look up the rightmost active return line number, which is this one, and just make a note that we should continue execution on line 15. That is not a problem. The second thing, on the other hand, is destructive, because we will take all the columns that we allocated for this invocation and say, well, let's go ahead and deallocate all of those. Okay, so we'll go ahead and deallocate all of those columns, which means after this point, we don't really have a parameter x and parameter y taking up column F and column G anymore. They are now deallocated. And we now continue execution on line 15. On line 15, which is the end of the subroutine sub 1, right at this point, the local variable x and local variable y of subroutine sub 1 never got changed. Okay? They got initialized to 46 and -7 on line 12 and line 13, and they were never changed after that. Okay, so that means even though the swap operation, the logic of the swap operation was correct, but because we were using by value parameters, nothing really happened to the original items. Okay, so let's go ahead and finish this trace first, and then we'll go ahead and explain, I'll give you one analogy of what passing by value is kind of like, so that it will help you guys remember what it is and the limitations thereof. Okay, now that we are done with the trace, I'll just kind of give you an analogy of what passing by value really is. Okay, when you go to the DMV, very few people actually walk into DMV anymore these days. They just do most stuff online. So let's say you submit a form to the other person. Okay, now when you submit a form, through an inbox, in most cases, the other person gets the original form. So when they mark up the form, it is the original form. Passing by value is not like that. Passing by value is more like, instead of an in tray, it's a copier. Okay, if you want to submit a form, if you want to submit anything to the person in the office, you put the original form on the copier, and then the quote-unquote submit process is to press that button on the copier. The other person is not getting your form, but getting a copy of your form. Am I getting that point across? Okay. So that's why this is not working, because swap as a subroutine is not getting your original x and your original y in sub 1. Instead, it is getting a copy of those particular variables. So that means swap can do whatever it wants to do with the parameters, but nothing is going to happen to the original. And that's why we have a problem. Okay, that's why it was not successful. Are there any questions about the program, this program, and why it is not working? Because the purpose is to exchange local variable x and local variable y of sum 1, but it's not achieving that purpose. Okay, so let's go ahead and fix this program. The syntactical change to this program to fix it is really simple, but the mechanism involved in this change is actually kind of significant. It is not as simple as it seems. The first thing we do is we change the type of the parameters from by val to by ref, which is passing by reference. Okay? And then the second thing that I have to do in this class is to change the arrows, so it becomes a double-sided arrow like this one, and the other one the same way. Instead of having a right arrow, it becomes a double-sided arrow like that. Okay? And that's it. That's the only change I have to do syntactically speaking. But when you execute the program, the behavior of this program is now quite a bit different from the previous one. So let's go ahead and trace it again. Yep.
So if the normal arrow in actual code is an equal sign, what would that be?
That is, well, the arrow was never really an assignment operation. It really it's just saying, okay, use this expression to specify that parameter. In this case, it's the same thing. The one on the left-hand side is the one that you have access to. The one on the right-hand side is the parameter of the subroutine that you're invoking. So when we get to that point, I'll explain that. All right. So the first part of the execution of this program is identical to the one before, so I'm not going to spend too much time to talk about it. So precondition, starting on line 16, we have return line number being post, and then we have local variable x being unknown, local variable y also being unknown at this point. Oops. And then in the subroutine, starting on line 12, x gets a value of 46, and on line 13, y gets a value of -7. So the first part of the execution of this program is the same as the one before. Not really exciting, but by the time we get to line 14, something strange is happening. We still have to allocate for the return line number. We still have a parameter x, we still have a parameter y, and we still have a local variable t. Local variable t, being a local variable, still starts with an unknown value, and the return line number still has to go back to the line that is logically following the invoke statement, which in this case is line 15. So that part is the same as before. The question now is, what do we use to specify parameter x now that it is passed by reference? And also the same thing for y. What do we use to specify y now that it is passed by reference. Okay, so the answer to that question is x as a parameter, as a passed by reference parameter, it doesn't have a value anymore. Okay, what it has instead is a reference to another column, or in other words, x as a parameter passed by reference becomes an alias of another column. So in this case, it depends on what we use to specify this particular parameter. On line 14, which is the invoke statement, we use this x here, which is referring to local variable x of the subroutine that is, of whatever code that is doing the invocation. That x is using which column? Can someone tell me?
C.
It's using column C. That's right. Okay. So local variable x of sub 1 is column C. So that means the passed by reference parameter x is also going to be referring to column C. And the way I represent it in this class is aka column C. In other words, parameter x of swap does not have a value anymore. All that it is just an alias of another column. You cannot store anything in column F, okay? You cannot retrieve a value from column F, because whatever you do with column F, now you have to actually do it with another column. It is just an alias. It's another name of another column. Are we doing okay so far with that concept? Okay. So y is the same way, except I'm not using column C to specify y, because according to the invoke statement, I'm using local variable y, which is column D, to specify parameter y of swap. So y becomes aka column D. It is an alias of column D. Okay, so I'm gonna see if I can make everything appear on the screen at the same time. I need to decrease the magnification just one notch, just to so I can see everything at the same time. Okay, now that I set up the columns like this, how do we make use of parameter x, and how do I make use of parameter y? That's the question. Line 5 is not going to show you much. Okay, line 5 is going to show you some, but not much. The right-hand side of line 5, excuse me, refers to x. We look up x from right to left. The first x that we encounter is column F, which is my parameter x. That tells me that x is an alias of column C. So that means I have to look up column C. Column C has a value of 46. So that means this right-hand side on line 5 evaluates to a value of 46. Now that part is not too hard. Looking up an alias and find out what it really is not difficult. We use that to update local variable t. So as a result, local variable t gets the value of column C, which is 46. Are we doing okay so far?
Yeah.
Well, other than
T.
that part. Okay, but line 6 is the line that illustrates the main differences between a by-val parameter as opposed to a by-ref parameter. What does it mean when we pass a parameter by reference? The right-hand side of line 6, once again, is fairly easy to understand. It's referring to y. You look up the definition of y from right to left. The first y you encounter is column G. Column G says y is an alias of column D, and column D has a value of -7. So that means the entire right-hand side of line 6 is really just specifying the value of -7. The question is, what are we doing with -7? In other words, what is the left-hand side specifying? The left-hand side of line 6 specifies x. We look it up from right to left, and the first definition of x that we encounter is column F. Column F refers to column C, so we are trying to update x here. So what am I actually going to update? I'm not going to update column F. I do not write a value here.
Go column C.
Instead, we go to column C and then update it. So on line 6, it is column C that is being updated to a value of -7, and not the other column. It is not the parameter column F that is getting updated. It is the column that it refers to that is getting updated. Are there any questions about this mechanism? Because this is the difference between a passed by value parameter, where you just update the parameter itself if there's an update, versus a passed by reference parameter, where you do not update the parameter, but you update whatever it refers to. Yep.
Does it just look at the rightmost active one? So if there's multiple subroutines, it would just take the one immediately to its left.
We take the well when you look up x, then you look up from right to left. So since the first x that we encounter is column F, so you use column F to determine what you need to do next.
Okay.
And that's assuming your program is written correctly, which means you write your program in a way where x either refers to a global variable or a local definition to the subroutine.
So if you had another one on there, it would automatically look to column F first, and then it would use that to look at column C.
No, because column
Unless
F
you
is
designed it that
always
way.
referring to something, and you update whatever column F is referring to.
Right, I'm saying if there was like another.
Well, if you made another one, then if you were trying to update the original X, then you'd just say refer to, or AKA column C again. So it'd skip F and just go straight to C.
Right, but how is that designated in name?
It's the notation.
But how? It just says
Because
the
it's
X
saying
would give another
it
X.
says X. Basically, it's saying that the X from colon at F is to refer to whatever X that is being referenced beforehand, specifically that one.
Right, so if you had another one in, it would
Another
apply
one.
the one on column F, which applies the one on column C.
It doesn't necessarily apply the one on column. I think I missed.
Okay, but I need to understand what.
Another of the double-sided arrow that the fire at is.
Another level of invocation?
Yeah.
Okay, if you have another level of invocation, you still have to follow the same mechanism, which means whenever you pass something by reference, it is always going to become an alias of another column.
Right, my question was how do you know which column it is? Is it just the one?
Oh, okay, I see what you mean. The way you know which column it refers to has to do with the invoke statement. That is all set up when we executed line 14. Okay, so let's go back to the execution here on line 14. When we executed line 14, which is here, we do the usual invocation thing, which is to set up the return line column and also one column for local variable t. So those are basically the same as before. But when we set up by reference parameter x and by reference parameter y, then we have to look at how we use what we use to specify those parameters. The x on the left hand side refers to the x of sub 1, which is my local variable x. And local variable x is using column C, and that's why parameter x of swap ends up an alias pointing to column C also.
Okay.
Is that explaining what you were asking?
I think so. So if I'm like 7.5, there's another biref to x, it would look at the biref for sub swap.
Say again?
If there was like a 7.5 that had another invocation of swap,
Okay.
it would look at line 2, right, first, before looking at line 10.
That is correct.
Okay.
Because when you look up a name inside the subroutine, you look up from right to left in terms of the columns.
Okay,
So the
alright.
first definition of x you encounter is the one that is here.
Gotcha.
Okay.
I have a question.
Yep.
The double arrows on line 14, the
Mhm.
invoke swap, that's by reference.
Yeah, it's basically indicating, it's just, for this class, it's only for pseudocode. When you actually program this in C and C++, there's no mentioning of the parameter name itself. You would just be using X and Y. But in this class, I use double-sided arrow to indicate whatever is on the left-hand side is the same as whatever is on the right-hand side. It's not a copy of that anymore. They are basically the same thing. One becomes the alias of the other one.
How do you know the difference between by value and by reference?
You can only, in this class you can tell from the invoke statement, because now it's a double-sided arrow. But when you're programming in C, you do not until you look up the definition of the subroutine that you're invoking. Then you can tell whether it's a by reference parameter or a by value parameter.
When would a by value, the method of by value, when would that work out? How would that help?
A by value parameter is useful, for the purpose of kind of like something that you only need to get in, but you don't need to get anything out of it. So if you just want to tell someone, okay, this is the address that you need to go to, but you don't need the address back because there's nothing to be modified that you need to get back, then it's a by val parameter. It's just a one-way thing. You're just passing the information to the subroutine. On the other hand, if you're asking someone to sign a piece of paper and then get it back, then you cannot use a by val parameter because but the by val mechanism is making a photocopy. So the person ends up getting a photocopy of the form that person is supposed to sign, and nothing happens to the original form that you want that person to sign. So in that case, you have to use pass by reference, where the person who's supposed to sign knows where to find the original form, the form that actually needs to be signed. Are we doing okay so far at this point on line 6 of swap? Okay. If that's okay, we move on to line 7. Line 7 is not much different, except the right-hand side refers to local variable t. Local variable t has a value of 46, so on line 7, the right-hand side is really just 46. The left-hand side refers to y, and once again, we look up the names from right to left. The first y we encounter is column G, but column G as a passed by reference parameter means that we cannot change column G, we can only change what it refers to. In this case, since it refers to column D, which is here, this is the column that we update to a value of 46. So that means inside the subroutine swap, when we executed line 6 and line 7, we ended up modifying something that did not belong to swap. But that's okay because we were using the pass by reference parameters, and that gives us the ability to change something that does not belong to this particular subroutine.
Then when it terminates, it doesn't matter.
Yep. Well, let's see what happens when we terminate. When we get to line 8, which is the end of the subroutine swap, we have to do the usual thing. First, to look up the rightmost active return line number, it tells us to continue execution on line 15. That part is the same as before. And then we do exactly the same thing as before, which is to look at all the columns that we allocated for this invocation, and we deallocate every single column. But this time, there's no problem, because what we are deallocating is not column C or column D. All we are deallocating are the references to column C and column D. And it's okay to destroy the references to those columns, because those columns were updated already, and these columns are still there at the end of line 15. Oh, excuse me, at the end of line 8. Are we doing okay so far with that concept? Okay. So now we are on line 15, which is the end of the other subroutine. We have to destroy the actual x and y because they are local variables. So in this case, we have to continue execution at post and destroy these 3 columns in this case. And that ends the trace of this particular program.
But does that now destroy the value of x and y?
Right. Yeah. The local variables x and y are now destroyed. Yeah. We didn't really get a chance to make use of those values after the swap operation. But you can kind of imagine that if we have like 14.1, after the exchange operation, then we'll be making use of the exchanged versions of those variables. In other words, if we stick a few lines between line 14 and line 15,
Yeah.
those will be now. So at that point, the y will have a value of 46, and x will have a value of -7.
But I thought it just got destroyed.
Well, it got destroyed on line 15.
Yeah.
But I was saying, if I had several lines between line 14 and line 15, those
okay.
lines will use the exchange version of those.
I was looking over on the trace.
Right.
I didn't understand what was the problem with the
Bival?
bival.
With the bival version, nothing really happened to column C and column D. Okay, let's go back to those. Okay, so if I go back to the bival version, so this is the source code of the bival version. Bival single-sided arrow. When we go to the trace of the bival version, which is here, you can see that column C and column D never got updated. Okay, let's just focus on these 2 columns. You can see that nothing happened to those columns. But when you look at the by reference version, this is the source code. and this is the trace. When you look at column C and column D, they got updated, and they got updated by the subroutine swap itself. And that's the main difference between these two mechanisms. Because one is passed by value, which means you're giving the subroutine a copy of something. And then the subroutine can do whatever it wants with a copy of something, and nothing happens to the original. When you have passed by reference, you are not passing a copy to the subroutine. The subroutine technically is getting a method to find the original item. It's just like, when you want to check out a book from the library, you can use a reference number or a call number. And a reference is a call number, basically. It's a way to find a book. So at the end of the subroutine, it's perfectly okay to destroy a little slip of paper with a call number written on it. Because you can destroy the call number or the slip of paper with a call number, but nothing will happen to the actual book in the library in the process. Are there any questions about this particular program? Why, changing by val to by ref, now we actually, can change the values of the local variable x and local variable y in sub 1. No questions? Okay. This one actually illustrates pretty much everything that you need to know to get the homework assignment done. Okay. Are there any questions about this one? I mean, what you can do with this one?
When
Okay.
does this assignment due?
In a week, so next Thursday. All right. Well, let's go ahead and take a look at another program that involves passing by reference, and this time we'll have what we call an aliasing problem. In other words, we end up with two pass by reference parameters referring to the same column, and the question is, one, is it okay? And two, if that is the case, what's going to happen to the program? So we'll go ahead and define the subroutine first. So we'll define the subroutine, let's call this sub 1, okay, because it doesn't really do anything particularly interesting. We have pass by reference x, pass by reference y, and the code is to say x gets x plus 2, y gets y minus 2. Okay. And define sub. So when you look at this subroutine, it doesn't look it doesn't look particularly challenging. All we're going to do is to update the value of whatever x refers to by 2, and we'll increase it by 2, and whatever y refers to, we'll decrease it by 2. That's the purpose of this particular subroutine. So now we take a look at another subroutine. We call this sub 2, and in sub 2 I have, let's say, a local variable v, and v starts with a particular value, let's say 10. Okay, that part is not important. And then what we do is we'll invoke sub 1, and this time I can use v to specify parameter x as well as parameter y. Okay, and we want to find out what's going to happen with this program. Is it really okay? And if so, what is going to happen when we get to the subroutine sub 1? So I'll fix the indentation first, and then we'll trace it. Okay, over here we add one more sheet for the trace. Once again, there are no global variables, so the precondition really has nothing to say, and then we can move on to line 12 right away to invoke the subroutine. When we invoke sub 2, we have to allocate one column for the return line number and one column for every local variable or by value or by reference parameters. In this case, we only have one local variable v, so one additional column is needed. V as a local variable starts with an unknown value, so we put a question mark here. The return line number is post because line 12 is the last line of this entire pseudocode, so we are pretty much done with the setup of the columns, and now we can continue execution inside sub 2. Inside sub 2, we start with line 9, which is not very exciting. V as a local variable gets a value of 10. Then we move on to line 10. Okay. Now, when we get to line 10, we know that we have a return line number. We also know that for each parameter or local variable, we have to reserve a column. In this case, we need one for x and one for y. the question is, well, return line number is the easy one. The invocation is on line 10, so that means when the invocation of sub1 is done, we have to come back and continue on to line 11. But what should we specify here for column E and also for column F? What do you guys think? What am I using to specify parameter X, and what am I using to specify parameter Y?
AKA column.
In both cases, it is AKA column C, because local variable V of sub 2 is using column C. So as a result, the passed by reference parameters X and Y are both going to be aliases of column C. So this is AKA column C, and this is also AKA column C. Are there any questions about this part of the execution up to this point? Well, it's okay. I mean, this is still consistent with everything that we have talked about up to this point. Now the question is, what do we do on line 4? Well, nothing really different from what we did before. The right-hand side of line 4 refers to x plus 2. So we look up the definition of x from right to left. The x that we encounter first is column E, but column E doesn't really have a value. It is an alias of a column that has a value. So that's why we have to go back to column C and say, oh, okay, I can see the value is 10. 10 plus 2 is 12. What do we do with 12? We want to store that back into x. So we look up x from right to left again, but we cannot store in column E because column E is an alias of another column. We cannot overwrite an alias. So we can only overwrite whatever the alias is referring to. So in this case, column C is the one that we are going to change. So column C is the one that is updated from 10 to 12 on line 4. Are there any questions about the execution of line 4 in this particular program?
So the value is unchanged. It becomes unchanged after that.
Okay, what is unchanged?
It goes
Which
back-
column?
Well, V goes back to the value of 10 after both of those operations.
After line 5, yes. But as far as line 4 is concerned, it did change column C to a value of 12. Okay? So when we execute line 5, yes, you are correct that we will revert it back to 10, because when we execute line 5, the right-hand side is y minus 2. We look up the definition of y from right to left, and the first one we encounter is column F. Column F does not have a value. It is an alias. It's an alias of a column that actually has a value, so we have to look up column C when we evaluate line 5, or the right-hand side of line 5. But column C does not have a value of 10 anymore. It is now 12. So we are looking at 12 minus 2, which is 10, and then we store that 10 into y. We look up y from right to left. It is an alias of column C, and that's why we store 10 over here in column C instead of column F. So by the time we get to line 6, it is as if we didn't do a single thing. But that's only because x and y are both referring to column C. We first bump it up by 2, and then we decrease it by 2. And that's why by the end of subroutine sub 1, it is as if we didn't do a single thing. But we actually did. Is that okay so far? And whatever we did not do it to column E or column F. Whatever we did it to column C. So now, when you go to line 6, we are deallocating the 3 columns that we allocated for this invocation. So we'll go ahead and get rid of these. And when I said get rid of those, I'm just saying that we should indicate that these columns are now deallocated, and then we continue execution on line 11 because that's what the return line number is telling us to do. On line 11, it's the same thing. It is the end of sub 2, so we look up the return line number, make a note of that, and then we have no use of column B or C anymore. They are both now deallocated. And that ends the execution of this particular sample program. So the purpose of this program, to illustrate, it is okay to have 2 passed by reference parameters referring to the same column. It's perfectly okay. It's the same mechanism as all the other examples. Are we doing okay so far with this example? Okay. So now that we understand what is passed by reference, we can try to redo the factorial program using passed by reference and see if we can get away from global variables altogether. If you want to remember certain rules about programming, certain guidelines, the first one is copy and paste is bad. Okay, because if you copy and paste code and whatever you're copying from has a flaw, now you're just replicating that flaw all over the place. Which means if you have to fix it, when you fix your program, you have now multiple places to fix. So it is much better to use a subroutine to only have one copy of one code, so that you don't have to deal with multiple copies of the same bug everywhere in the program. Yep.
Oh shoot.
There's no row sheet anymore because we're past the last day to drop a class. So I cannot drop anyone from the class, and you guys cannot drop yourself either.
We're stuck together.
We are stuck now, yes. And if you think about it, at a UC or a CSU, I think the last day to drop a class is like 2 or 3 weeks from the beginning of the semester, and then after that, it's like stuck. It's only at a community college where we can still drop from a class like 3 or 4 weeks from the end of the semester. I don't think it's really helping anyone, but it's how it's set up.
It kind of helps if you thought you were going to do a lot better in a class and you're just not doing well, so it gives you that chance to, once you kind of know what your final grade might be, it gives you sort of a chance to pull if you need to.
I think they're looking bad, better pull out. No.
Well, at a CSU and a UC, it's also a lot more costly to drop a class.
Yeah.
Yep. If you don't drop it like within the first 2 days or something like that, you don't get a refund, and it's expensive at a CSU or UC. All
They
right.
like their money, and they don't like giving it back.
No, they're not going to give it back to you.
America's heavily based on charges for education. I think so.
I disagree with that.
One of the
In my place,
one of the few.
because in Europe it's a charge.
Yeah. Assuming you are a resident there. They charge you if you come from over here.
My friend in Britain, my friend in UK, he goes to, like after high school, he goes straight to college, and they pay like I think the first 2 years or whatever.
Well, in some countries, you may not pay for your education, but if you try to there's no deviation from the path that the government has planned for you. You will become a car mechanic, but I don't want to. I want to study computer science. No, you will become a car mechanic.
I don't remember asking your opinion.
Hmm?
Yeah, the government.
We'll listen to your opinion and then ignore that.
And I think in Japan, they
Yeah.
you have to pay for it.
In Japan, if I understand it correctly, they also have an age limitation, so you can only get to a certain educational institution within a certain age group. If you're out of that age group and you try to go back to college, it becomes really difficult. I don't know whether it's really just is it really the rules of admission, or whether it's just a cultural thing, but it's difficult. It's much more difficult than in this country where everybody can just, I want to go back to college. Okay, that's fine, no
Awesome.
problem.
We got colleges over there.
Yeah, but not in Japan. In Japan, you have to follow a path, and you have to follow it like
Diligently.
exactly. Yeah, you cannot deviate. If you-
Exactly.
Yep.
I think you're allowed to, you're allowed to not go to high school. Just go to a job. after middle
Trade school, like a
Yeah.
trade school.
Maybe not even that.
Yeah.
Just go.
It's
get-
more
you start
structured.
working.
Yeah, one way to describe it is more structured.
Yeah.
Yep.
Japan is not the place for you.
Okay, so what we'll do is we'll rewrite Factorial, but using by value parameter as well as by reference parameter. And this time we'll see if we can get we can stop using global variables also. One thing is so getting back to what we were talking about before, copy and paste is bad. The second thing that is also bad, in fact it's worse than bad, is global variables are evil. Okay, so if you have to use global variables in a program, you have to kind of think about, do I really need to use global variables? if you copy and paste, you have to think about, do I really need to copy and paste? Because those two things can get you into trouble. Yep.
Oh,
Question?
so in this program, we're gonna use by ref and by val, or just one?
Yep. So in place of a global variable, you can use by val, by ref, local variables, or a mechanism that we may or may not be able to get to today, which is returning a value. So those things can usually replace the need to use global variables. So we'll take a look at Factorial first. So we'll go ahead. I keep using Factorial because it is a program that it is a subroutine that we have talked about many times already. And each time we redo it, we are just introducing a new concept so you can compare and contrast and say, well, how is this different from the last time we did it? So in this case, we have by val n, because the variable n or the parameter n is only telling Factorial, we are trying to find the factorial of this number. So it is a input only type of thing, and it is passed by reference. In this case, the result is passed by reference because we want to pass it back to the caller, and that's why it's passed by reference. So in here, it is the same thing. We have if n is greater than 0, then we will do the recursion. In this case, the recursion goes like this. We invoke Factorial. We use n minus 1 to specify n, and then we use r to specify r. Because whatever r I'm supposed to store the result, I'm going to pass it along to the next invocation and say, hey, you know what? You are supposed to store your result in this, whatever this parameter is referring to. But when this invocation of Factorial comes back to me, then I have the factorial of n minus 1, and to figure out my own factorial, I just have to say, well, whatever the factorial of n minus 1 is, which is stored in R at this point, I just have to multiply that by n to get to my own factorial, because I am dealing with the factorial of n. Okay. Else case is R gets 1, because when n is equal to 0, the factorial is just 1. And if, and define sub, and then we'll go ahead and fix up some indentations. 1, 2, 3.
Wouldn't it be better to put if n is greater than 1? Because if n equals 1, then it'll
technically
also do
speaking,
that.
yes, you can do it, but when you look up the definition, they terminate with 0, because there's one way to arrange nothing. That's why the factorial of 0 is 1. So in main, we have a local variable. Let's say it is I, and then we just have to say invoke factorial. We'll try 2. Okay. So we use 2 to specify n, and then we have to use I to specify r. You have to specify r with something that has storage, that has a column. So I is a local variable, and that's why I can specify a column. And define sub, invoke main. Now, there is a particular reason why I named this subroutine main, because when you move on to the next class, the subroutine with the name main has a special meaning. Because instead of starting execution from a line, from the first line that is outside of the definition of a subroutine, when you move on to the next class in C and C++, and also in Java, execution starts with a subroutine called main. And that's why the subroutine called main is special, because there's an implicit invoke main somewhere that you cannot see. And that's why that's the entry point of the entire program. And we are kind of slowly shifting into that kind of frame of thinking about how do I get my program started. Okay. All right. So let's take a look at the execution of this program, or the trace of this pseudocode, and see what it's going to do and whether it is really that much different from before. And I can tell you it's not really that much different. So we do need one column for comments, because we have a conditional statement on line 4 to evaluate a condition. And the first line, which is the precondition, now has nothing to say, because I don't have global variables anymore. So the combination of local variable I and passing by reference basically eliminated the need of a global variable because I have a way for a subroutine to modify something that doesn't belong to it. Okay, so we'll start execution on line 15. Main doesn't really do anything. Main is really just a container. It's a starting point of the entire program. So it has a single return line number to post and a place to store local variable I. That's it. So column C, column D are here. And then we move on to line 13 inside the subroutine. Inside the subroutine, we are invoking Factorial. When you invoke a subroutine, you have a return line number, and then we have to allocate one column for each thing that we define inside the subroutine. In this case, we have a one by-val parameter n and one by-ref parameter r. The return line number is line 14 because the invocation is happening on line 13. N is clearly just 2 because that's pretty clear that we are using 2 to specify parameter n, which is passed by value. What are we using to pass to R? We are using local variable I to pass to R. So R becomes an alias of whatever I is, and I is using column D in this case, and as a result, R as a passed by reference parameter is also an alias of that column. So this is also known as column D in this case. Are we doing okay so far? Okay. Now that we have set up all the columns, we can now continue execution in the subroutine starting on line 4. On line 4, the first thing we have to do is to evaluate the condition. Is n greater than 0? Oops, wrong window. N is greater than 0 is true because n has a value of 2 and 2 is greater than 0. Then we move on to line 5. Line 5 is the invocation. So this time it looks kind of confusing. I'm trying to look, let me see if this works better. I'm going to try to resize it, but I have to control it more precisely. So I'm going to do it this way and turn off some of the toolbars. I can turn off the formula bar. I can turn off my status bar. I can turn off my formatting bar, I suppose. Yeah. And also this bar here. And that was my standard bar. Okay, that gives me more room. That's the whole purpose of turning off those toolbars. And this way we can display the trays a little bit wider than before. Okay, so we are now on line 5. Line 5 needs to set up a few columns. This is a recursive call. We are in Factorial already. But it doesn't really matter because every time you invoke Factorial, you have to kind of go through the same steps and allocate the same columns. So we'll deal with the columns first. We have to allocate one column for the return line number, one column for R, and one column for N and one column for R. And then we want to go back and say, but how do we populate those columns? Just adjusting the width of the columns a little bit here. Okay, we're on line 5. The return line number is the easy one to deal with because the invocation is on line 5 and there is a line 6 to execute when we come back. So the return line number is just line 6 here. And let me spell line. There we go. R is, okay, we use R to specify R. But remember the one on the left-hand side is the R of this invocation, the invocation that is active at this point. The invocation that is active at this point has column G as R, which is an alias already. So the question is, when you pass an alias along to another subroutine, what are you really passing? Okay, two options. The first option is, I'm just passing the alias along, and that's it. Second option, I'm passing an alias of the alias. Okay, which one do you think is the answer?
Either.
Technically the second one, but couldn't you circumvent that by just making it the first?
Well, technically it is the first one. The mechanism specifies that when you pass an alias along to another subroutine that is also passed by reference, you're just passing the alias itself along. So in this case, because R of column G is already an alias of column D, I'm using it to specify the R of the next invocation. The next invocation, or the R of the next invocation, is really just the same.
Yeah.
Which, in other words, this is really just, AKA column D.
When I said technically, I was meaning like just to keep the structure, but yeah, it just tosses it around.
Yeah, so when we pass a reference along to another subroutine, we're just passing it without, so if you end up with an alias that goes to another column that is also an alias, something is not right. Okay? In this class, we don't do that. Is that okay? Does everybody understand what I meant by that? So if you have AKA column something, and then you look up that column, it is also AKA something, then something is not right. All right, so what about n? Well, n is not really too bad because, it looks really kind of confusing because we are using n minus 1 to specify n, how can that happen? Well, remember the one on the left-hand side refers to the n that we already know at this point with the current invocation. So that n, this n here, really refers to column F, which has a known value of 2. So 2 minus 1 is 1. Who is going to receive that value of 1? Well, it is n, but that n is not column F anymore. That n refers to column I, which is the n that I'm setting up the next invocation. So column I is the one that ends up with a value of 1 as a result. Are there any questions about how I set up columns H, I, and J? Yep. Question? No? Okay. If there are no questions about this step, we'll move on to the next invocation. So once all these columns are all set up, we can now continue execution from the beginning of the subroutine that we're invoking. In this case, we are starting with line 4 again. Line 4 is evaluating n is greater than 0, and we look up the definition of n from right to left. So if you look it up from right to left, then the n that we have to use is going to be the one in column I and not the one in column F, because remember, we have to look it up from right to left. The one on column I has a value of 1, 1 is greater than 0 is true. So we follow pretty much the same path as last time. We have to continue on to line 5. Line 5 is invoking factorial recursive again. So we basically will be setting up things almost exactly the same way with only one difference. The one difference is basically n. N is now 0 instead of 1. But other than that, it's the same mechanism. We still have to allocate the 3 columns. And I'm going to decrease the zoom one more time just so that we can see all the columns at the same time. Okay, now that we have all the columns set up, we go to the subroutine. We go to the beginning of the subroutine that we're invoking. So once again, we get to line 4. Line 4 is still, looking for the same thing. N is greater than 0. But this n is referring to column L because we look up the definition from right to left. So this is the first n that we encounter. It has a value of 0. 0 is greater than 0 is false. So we don't go for the true or the then branch anymore. We go to the else branch. The else branch is on line, line 8. And line 8 is just going to store a 1 into R. But that is no longer just a simple thing to do, because when you want to store 1 to R on line, is it line 7? Yep, line 8, sorry. So on line 8, we want to store 1 to R. So we look up R from right to left again. The first R that we encounter from right to left is this R here, but we cannot store anything into column M because R is a reference. It is an alias of another column. So you have to look up what it is referring to. In this case, it's referring to column D. Column D is the one that is now updated to a value of 1. Are there any questions about the effect of line 8? Let me show you both these trays as well as line 8 itself. Are there any questions about what we did on row 14 of the trays? Is it pretty consistent with what we have talked about for this entire lecture?
So
Yep,
Yeah.
same thing. It is just an alias. when you see an alias, you don't update the column that is the alias, you update the column of the referred to by the alias.
Like the source, yeah.
Yep. All right, so now that we are done with line 8, we get to line 10. We get out of the conditional statement, we get to line 10. And the rest of this program is not going to be very exciting anymore. So on line 10, what we do is we look up the return line number from right to left. It tells us to continue execution on line 6. And then we have no use of these 3 columns anymore. And we just get them deallocated. I can see the effect of getting close to the end of the semester.
Those guys will have bad grades.
Maybe.
Or they'll be watching a lot of videos.
But the mechanism of passing by reference as opposed to passing by value is actually important because the same mechanism exists in almost every programming language. So it exists in C, C++ for sure. It also exists in PHP, Perl, and also Python. So they all have a mechanism to do pretty much the same thing. All right, so we are back to line 6. Line 6 wants to, come on. It wants to compute the product of R and N and then store that into R. Now, the most important part is to keep track of our context. We look up N using the right to left order. So the rightmost one that still has a value is column I. It has a value of 1. R, on the other hand, is column J, but column J does not really have a value. It is just a reference to another column that has a value. Column D has a value. 1 times 1 is 1, and then we store 1 back into R on line 6. After line 6, we get to line 10. And on line 10, we look at the return line number. We make a note that we have to continue on to line 6 next. And then we have no use of these 3 columns anymore. I'm just copying and pasting from here. And then we now continue execution on line 6. Line 6, once again, wants to compute the product of R and N. N is now column F because we have to look up from right to left. But these other ones are all deallocated already. This N has a value of 2, R has a value of 1, the product is 2. So we store that 2 into R. R refers to column D. Column D is the one that is now updated to a value of 2. After line 6, we continue on to line 10. Line 10 once again has to look up the rightmost return line number or the rightmost active return line number. In this case, it goes to 14. We make a note of that. And then we have no use of these 3 columns anymore. So we deallocate these 3. And now we continue execution on line 14. Line 14 itself is also the end of a subroutine, but this time it's the end of the main subroutine, which means we are pretty much done with everything that we need to do, but we still have to trace it. This tells us to continue execution at post, and then we have no use of the 2 columns that we allocated for main, or the invocation of main. We mark these 2 columns as deallocated, and then we get to post, which means we are all done. Are there any questions about passing by reference? I'm hoping that by now, when you guys hear about passing by reference, you just go like, oh man, that's boring. Because knowing that, I'm hoping it's boring for the right reason, because there are 2 reasons why something can be boring. One is, I know this already, come on, let's move on to something that's new. And number 2 is, I have no idea what you're talking about. That can also be boring, because I have no idea what you're talking about. Okay, so now we are pretty much done with passing by value and passing by reference. The next topic is returning a value. That can be kind of confusing. Okay, so before next Tuesday, I'm hoping that most of you will have a chance to read about it first. Okay, and then when we talk about it, hopefully it won't be as confusing as without reading it first. But returning a value is also a very important topic, because even though passing by reference gives us an ability to return a value from a subroutine to whatever is invoking the subroutine is cumbersome, because it still needs to refer to a column, so that you will need either a local variable or a by-val parameter in order to give it a space to store something. Returning a value means, nope, you can just return a value and make use of that value right away without having to store that in some place. Go ahead.
So basically, returning a value is like having a local variable here, but when you get out of it, it updates the original.
No, it is really kind of more. It's more interesting than that. Returning a value means if you have a subroutine that returns an integer value, you can put the invocation of that subroutine wherever an integer can be expected.
That's interesting.
So that is a very useful feature because it makes your program a lot more concise. Okay, okay. Let me say that one more time and then I'll answer your question. Okay, so with the ability to return a value, a subroutine can now be associated with a value of a particular type. So let's say you have a subroutine that has a return value of integer type. So instead of having to store the value to some place first and then refer to that place, which is what you need to do with passing by reference, now you can basically put the invocation of a subroutine wherever an integer can be expected. So it can go to the left-hand side of a multiplication, the right-hand side of a subtraction, or just any place you can expect an integer. That is the ability of being able to return a value. And that is very useful because it makes your program a lot more concise. Now let me try to answer your question.
So did you get the test exams graded?
No, it's not entirely graded yet. That's why you're not seeing anything yet. Okay. So I will basically let you guys know when it's all graded and I will expose the score all at once. All right. So I hope you guys will have a nice weekend. Looks like it's going to be a nice weekend. It's going to be the last weekend that is still nice and cool.
Well, a good amount of running for my physical activity.
Are you measuring the temperature? Or the voice? Are you trying to record the noise from the...
It's like making a crazy alien sound.
Oh, okay.
Yeah, that's important.
Well, it's talking to me. It's asking me to go back to the mothership.
Yeah. Thank you.
I was like, oh no.